Hello, everyone, and welcome to today's webinar. I will be your host, Andrea Thompson, the Marketing Manager here at GTT. We estimate that today's webinar will run approximately 30 minutes. We do encourage you to ask questions in the chat section. Unfortunately, it's really hard to open up the line with this many people on. But if you do have a question during the event, please send me a chat message and I'll try to relay the message to the presenters, or we'll answer it at the end of the session. If we don't get to your question, we'll address it individually with you afterwards as well. We are excited to introduce our latest solution for the transit market, and to tell you more about it will be our product manager, Chad Mack. And to assist him, we have two of our sales engineers, Craig Kairis and Paul Fellows, and they'll help share what they've seen while working with different agencies. So with that, I'll turn it over to Chad.
Great, thanks, Andrea. And thanks again to everybody on the line for taking time out of your busy day to learn more about this exciting new platform from GTT, the Opticom Connected Vehicle Platform. The platform represents a culmination of really years of effort and thousands of hours of development, excuse me, by the GTT team. So it's a product we're very excited about, and hopefully by the end of this webinar, you will be as well. But before we get into that, what I'd like to do is take a few minutes, set some context around the challenges that are facing transportation today that are driving the need for improved technology. From there, we'll get into TSP and the value that it provides, and then we'll jump into some of the public transit solutions that are available from GTT, and specifically the Opticom Connected Vehicle Platform. Get into the components, how it works, and the benefits that it can provide for your public transit systems. And then we'll wrap up the webinar with some discussion around deployment considerations, and not just considerations when deploying GTT or Opticom technology, but things you should consider when deploying any technology across your transit system. A couple logistics. So as Andrea mentioned, we have two of our technical experts on the line, Paul Fellows and Craig Kairis. They're going to be assisting me throughout the presentation. They're also here to answer technical questions, so I definitely encourage, as we work through the presentation here today, if you have questions, enter them in the chat, and we'll either work them into the presentation or we'll reserve some time at the end to address the ones we can get to. So with that, let's go ahead and get started. So if any of you have read the forward-looking or futuristic reports from the US DOT or other government agencies, they paint a very compelling picture of the future of our nation. And the first is that urban populations are on the rise, and not just because the US population as a whole is increasing, but rural populations are transitioning or migrating to urban areas. And so with that comes an increased need for goods and the movement of goods in cities. And so if you think about that, growth in people, growth in goods, leading to more burden placed on cities that weren't ultimately designed to support this level of people and goods, if something doesn't change, it will ultimately lead to a slowdown. That slowdown means wasted time for people, lost money for businesses, and ultimately increases in carbon emissions and negative impacts on the environment. So these are very compelling drivers to technology and the need for us to improve our city infrastructure. This also leads us to the concept of, the smart city, or the latest buzz around smart city and what that means. But if you look across the city, a smart city can really mean a lot of different things, not just improved transportation systems, but it means also improved energy systems and houses and the way we move and the connectedness of things. But for the sake of this presentation, rather than trying to solve all of those in 30 minutes, we're going to focus our efforts on what GTT is really good at, and that's the intelligent transportation space, and specifically public transit. So as we look at public transit and think about what types of things we can do to move people more effectively and more efficiently throughout a city, there are a number of questions that come to mind. The first, how can I keep up with demand without compromising my service? Or how can I reduce operating costs while still improving service? Or how can I improve on-time performance and ridership? So these are very obvious questions that come to mind. Fortunately, there's a technology that's been available for 40-plus years that can have direct benefits to each one of these, and that's transit signal priority, or TSP. So transit signal priority at the highest level really gives buses the green light to effectively and efficiently navigate intersections. And it does that in one of two ways. The first could be an extension to a green cycle. So the bus, as it approaches, has a couple extra seconds to get through the intersection in an efficient manner. The other way would be with red truncation. So you could more quickly cycle from a red to a green as a bus approaches so that the light is green by the time it gets to the intersection and can efficiently navigate that intersection without slowdowns. So as you think about these benefits, moving buses more quickly throughout a city, it leads to a number of very powerful benefits. These benefits have been proven through a number of independent studies by places like the US DOT or ITS America. In the particular study that I have referenced here in the slide, it talks about a couple of specific cities and the benefits that they were able to recognize with TSP. TriMet out in Portland, they were able to see a 10% improvement in travel time, a 19% reduction in travel time variability, and ultimately they were able to avoid adding one more bus to their service. So tremendous value there. Another city that was referenced in this report, Tacoma, Washington, they were able to reduce transit delays by up to 40% with TSP and signal optimization at the traffic controller. Another study that I have cited here talks specifically about the operating benefits of TSP, the ability to be able to cut your fuel costs by up to 19% and ultimately lower greenhouse emissions by up to 30%. So again, very powerful benefits of transit signal priority technology. But as you dig deeper into transit signal priority, what that is and what that means from a features perspective, there are really a lot of details that come to mind, especially as you think about every city being unique, every city having its own challenges, and every city having their own technology and infrastructure that requires TSP integration. So a couple of the items that I have highlighted on the slide. The first is the ability for buses to coexist with everyday traffic. So being able to have flexibility in configuring your TSP system to work with that. The idea of relative priority, as you think about holistically across the city, buses, high priority buses versus low priority, maybe those that are on more important routes or they have heavier passenger loads. Or as you think about emergency vehicles, which of those vehicles should have the right of way when they're both approaching an intersection at the same time? So the ability to manage relative priority is incredibly important as you look across the city. But then as you think about long-term deploying technology today that has to fit for future environments, the ability to integrate with existing infrastructure, things like AVLs or, again, EVP or traffic controllers. These are all very necessary things to have in technology today. And then you can take that a step further and look at not just moving buses more quickly and more efficiently, but moving buses more consistently. So only using TSP when the bus needs it. If it's behind schedule, using TSP to get that vehicle back on schedule. And then other things like conditional management to allow configurability for traffic engineers around peak hours, such as rush hour or special events, to configure TSP to work in different ways around those events to manage the needs of the city. These are all very powerful features that need to be considered when you think about deploying TSP. Craig or Paul, do you have anything else to add to that?
Yeah, this is Craig Kairis out in the great Northwest out here. Listen, again, I want to thank everybody for attending the call. I wanted to just talk a little bit more about the third bullet there, integration with existing infrastructure. One of the things that I find with many transit agencies is they have an existing CAT-AVL system that basically lets the network lets the folks in the network operations center know where that bus is at any given time, whether it's on schedule or not, and there may be a display in the bus itself to indicate to the driver that they're either late or not. But what's the direct link? One of the questions I often ask is, what is the direct link between the bus and the intersection? And in most cases, there isn't one. There isn't a direct link. When I ask transit agencies, when the bus driver knows that he or she is behind schedule, what do? Some of the responses I've gotten, well, jokingly, step on the gas. And I had one transit director, and this is a joke, mentioned, well, we just stopped picking up passengers. But in all seriousness, we did some webinars last year that was entitled Make Your Smart Bus Smarter. That is protecting that investment of that existing CAT AVL on the bus itself, but provide the direct link from the bus to the intersection to get to the previous slide to extend the green or truncate the red. And that's basically what we're talking about here with respect to making your smart bus smarter, is enhancing the capability of what you have, the CAT AVL on the bus, and making that request directly to the intersection from the bus, with the driver not having to do anything. It's automated. I often say, let the computers talk to each other and extend the green for that few additional seconds so the bus does not have to stop. And so we're engaged in several projects where, we're doing exactly that. We most recently, CTRAN down in the Vancouver area, Boise is another one where we leveraged the existing CAT AVL to make for conditional priority. For example, if the bus is, say, 2 or 3 minutes late, that's user definable. The CAT AVL system running schedule adherence makes that determination and then simply turns us on. Like I liken it to a light switch. If I'm behind 2 or 3 minutes, we turn the system on to extend the green. It's pretty straightforward.
Yeah, Craig, this is Paul. I'd like to add to that. One of the capabilities that Chad highlighted was a feature called relative priority. And we have a customer up in Ontario, actually. I know there's a couple of our Canadian friends up north on this call today that are using the ability to prioritize express buses over local buses. So that's using a feature that we have within the platform called relative priority, and that allows, again, the express buses to take precedent over the local buses where necessary. Again, in the theme of making your smart bus smarter, making your express bus a higher priority where necessary. Chad?
Yeah, great points, both Craig and Paul. So thanks for sharing that. I think some of the key points that you guys alluded to is, one, the ability for the TSP system to coexist and provide multiple functions for a city, but then also that the importance of integration with existing technology are two big ones. And as you guys will see, folks on the call will hear that the connected vehicle platform is designed to do those very things. All right, so let's switch gears a bit to look specifically at GTT's technology and our Opticom public transit solutions. So as we think about the solutions from GTT, the slide that I have here represents really two things. It's first the breadth of technology available from GTT to provide all of the feature set that we described in the previous slide, but it also represents the evolution of our product platform, starting 40-plus years ago with IR, where it was light-based, line-of-sight communication, and then evolving that to include things like GPS technology for very accurate vehicle locating and intersection communication, and now getting us to the connected vehicle platform, where we can leverage technologies such as cell and Wi-Fi to make these systems more integrated and more effective and efficient. One thing I want to highlight with the connected vehicle platform, we made a major transition internally at GTT, moving from traditional dedicated hardware focused around our specific feature set to more of an open environment, an open hardware platform, computer-based platform, and software applications. And in doing this transition, it allows GTT to be more flexible in the realm of integration, working with other systems and technology providers to integrate their systems with ours, not just by placing the systems on the same computer, but also potentially merging them to get expanded features that you otherwise couldn't have if you had independent products. And so with that, let's dig a little bit deeper into kind of our platform and the benefits. So if you start from the bottom and work your way up, again, the Opticom IR platform is really at the core of Opticom TSP technology. That was proven for over 45 years. We've evolved that over time to include new technologies such as GPS with our Opticom GPS platform. And now with the Opticom Connected Vehicle platform, we have this open architecture that's modular and expandable so that you can not only meet your city's needs today, but you have a solid platform to evolve your system and your technology base based on things that are coming in the coming years. Okay, so with that, let's switch gears and look directly at the Opticom CVP platform and what that is and what it's made up of. So as we think about the CVP platform, Connected Vehicle Platform, at the core, it's a modular and expandable platform to provide improvements to your transit system. And it's really made up of three core components. The first is on the hardware side. As I mentioned, there's a universal vehicle computer that provides the flexibility to integrate with the vehicle systems. And then there are peripheral devices, such as a Model 400 radio unit that can talk to our traditional Opticom GPS intersections. It also has software applications, things like TSP and advanced schedule management to do things like that schedule adherence or headway management to only use TSP when it's needed. And also applications like Centralized TSP for cities that have the appropriate infrastructure, networked infrastructure, or network connected intersections, and that back office piece. They can now deploy a centralized application either on their computer or on our Opticom Connected Vehicle computer to do that centralized TSP. And then the third component that we'll get into is on the management side. So the ability to remotely configure this system in settings from the comfort of your office is a major advantage, especially as you think about large cities and having to potentially touch every intersection. Being able to do that from one central location is a must, at least in this day and age. And then along with that, data and analytics. So once you have the system in place, how is the system performing and what modifications do I need to make or can I make to the system to make it run better? Obviously, these all need to coexist, and these are all things that we considered as we built out this platform. And with that, I'd like to transition it over to the technical experts to talk a little bit more about how the system works, and specifically our advanced schedule management system. Craig, do you mind taking a crack at that?
Yeah, on this slide we're all looking at here, one of the things that often comes up, and you hear it at various conferences, is a distributed versus a centralized approach, and it really depends on oftentimes the size of the customer, the infrastructure they have in place with respect to communication, what's physically running on the bus or not. So in the most basic form, and we've been talking about this under the guise of making your smart bus smarter, a distributed, obviously, as we've just discussed, that's where the bus is talking directly to the intersection. So the hardware and software, the computers on the bus are making that TSP call directly to the intersection, and then the controller, I want to make this clear, the controller is the final arbiter in the intersection. It decides through its transit signal priority software, how long to extend the green, and that's definable in the transit signal priority software running, in fact, in the controller. So they make the call, or the controller makes the decision based on the input from the approaching bus. The other thing that often comes up is a centralized approach, much like New York City did, where the decision-making process for the transit signal priority call is centralized at a transit operations center. So you've got applications. You basically have the bus typically through cellular communications, but it can be other forms. communicating back to a central site with its location, and then the servers, the compute power at that centralized location is deciding whether to grant that call or not. And if it's granted, if that transit signal priority call is granted, then that decision basically to extend the green is sent out via fiber optic to the controller at the intersection, and in some cases it might be cellular to the intersection. So it really depends on what the customer wants to do, what equipment they have. And we also have something, that's a hybrid approach where we actually have our software running on another CAD AVL computer, and we're talking via cellular to the intersection, and we can address some of those installations with you individually if you're interested. So my point is, it really depends on the strategic direction that the customer is heading, and what pieces they have today and where they ultimately want to evolve. The good news here in wrapping this up is that the solution from a distributed to a centralized approach, that we at GTT offer a migration path with various hardware, software, and communications components, including DSRC, digital short-range radio communication, to be able to do that.
Craig, that actually brings up a question I have here in the chat section. One of the participants is asking if the connected vehicle platform or advanced schedule management works with existing Opticom GPS systems.
Well, yeah, and that's the beauty of it. It does, in fact, offer a migration path. So we often get questions, well, again, can I piggyback on my existing cellular radio network? In Washington, D.C., they're doing that. Can we utilize Wi-Fi? Can we utilize, do we have a path towards the connected vehicle platform with respect to DSRC? And we're going to talk a little bit more about the hardware in a second here. But the answer to that is yes. And so we do offer a migration path that gets a customer from existing equipment to future equipment based on what budgets allow and what applications they're actually running today and what applications they might want to add in the future.
Great, thank you.
All right, so now why don't we switch gears a little bit, dig a little bit more into the details of the Opticom Connected Vehicle Platform. Paul, do you want to take a crack at walking through the hardware?
I do, yes, Chad. I want to reemphasize a couple slides ago what Chad mentioned about the history of the hardware components within TSP, the TSP industry. In the past, it's been a single-purpose device that took care of TSP. And with this connected vehicle platform, what we have is a more open approach for not only hosting the TSP applications, but the advanced schedule management applications that Craig just talked about, as well as other applications. And Chad will talk more about that in the software side. On the hardware side, it's important to note that we've kept that theme and provided an open hardware platform. We have a fanless design that a lot of maintenance agencies like, so that there's not another component that fails on the onboard computer. Plenty of storage, Windows 7 based. In terms of features, Andrea, can we forward to the next slide? I want to go over some of the components, the actual hardware connectivity components. Yes, as you should be able to see on this slide, the front and back contain industry standard components, whether Wi-Fi connectivity in the case of being able to connect to an existing network that might exist either at a bus depot or within the city. Industry standard USB, industry standard J1708 or 1939. Industry standard serial ports for the integration of other devices that may be required in order to load software information onto the connected vehicle platform hardware. And then on the rear side of the hardware, there is a discrete I/O. This allows you to, for example, connect the disable switch if you want to disable TSP at a near side stop when the door is open, for example. It does provide an Ethernet port as well for connectivity to other onboard devices that may be needed. Chad mentioned the 400 radio. If a customer has Opticom GPS, the connectivity to the 400 radio is through the Ethernet port. Video, in the event that you need to reconfigure the onboard computer, this is a PC, so no proprietary monitors. This would be an industry standard monitor that you would connect to it through the VGA port on the back. And then finally, your ignition sense and your power connectivity through a connector on the back. So again, in the theme of providing a much more open hardware platform than a single purpose device that we've had in the past, this hardware really sets the stage for an open software and services platform going forward. Chad?
Perfect. Yeah, thanks for that overview, Paul. That was a lot of good detail. So as we transition now to looking at software, I think this is one of the biggest advantages in terms of kind of strategic shifts for GTT in positioning ourselves to better serve customers today and in the future. And that's really this transition into more of a software application mindset. And so with the first release of the Opticom Connected Vehicle Platform, we will have two main software applications developed by GTT. That's the Transit Signal Priority application, which gives you the benefits of things like relative priority and conditional priority, with the end goal of ultimately moving your buses faster and more quickly throughout a city. But as you think about taking that a step further and saying, I don't want to just move my buses more quickly, I want to move them more quickly at the right time to ensure that they stay on schedule. That's where the software application Advanced Schedule Management comes into play, where you get more out of your TSP to ensure that you're not just moving buses more quickly, but you're really, at the end, driving schedule adherence or headway management. So those are two key applications that we're releasing right now. And then one of the tremendous benefits of this platform, kind of looking out into the future, is that, again, it gets back to the flexible open platform. So if you have other technologies that you're evaluating, maybe digital signage or automated voice systems or other vehicle systems that you need to integrate into a central location, this platform is designed to be just that, with a Windows-based operating system. And GTT is more than willing to work with customers to kind of cater this solution and modify our software applications to integrate more deeply with these applications, depending on, of course, what the need is. So this is a definite strategic shift from GTT's perspective to position us to be in a better place to serve you all as you look at technology needs today as well as in the future.
Chad, I'm going to interrupt you there for a second. There's a question relative to this as well. Does the system integrate with passenger counters?
Yeah, that's a really good one. That's an obvious technology that transit agencies are evaluating as they look at adding more technology to their buses. Generally speaking, that is a common one that we could deploy on this platform. But the questions we would ask then in turn is, what passenger counter are you using? Do they have a software application that can be ported onto a computer platform such as Windows? And then from there, what would they like to do with that passenger count information? Do they just need it passed to the central office, or do they want to use that information to drive transit signal priority based on passenger loading? All of these are things that we've dealt with in the past. But again, it's a perfect example of how we see this fitting for transit agencies. Craig or Paul, anything more to add there?
Well, I do. Yeah, thanks, Craig here. With respect to passenger counter, we actually have a customer on the East Coast, in Washington, D.C., that has a CAT AVL system, like I talked about briefly a few slides ago, but they wanted to integrate passenger counts. Just so to emphasize the point, they wanted to implement, they only wanted to make a transit signal priority call, one, if the bus was late, and two, if it was greater than 20% full. If it was less than 20% full and they were late, they didn't get a TSP call. So we've got various customers doing various things throughout the country here. So that was just one example. Chad?
Perfect. Yeah, great use case, Craig. And again, GTT is more than willing to work with customers to understand what their needs are and see how we can help to more effectively integrate our technologies with other technologies that you're evaluating. All right, so I want to jump into the last piece here, and that's the central management or the back office. So you've taken steps to deploy this great technology, but then you have to ask yourselves, or your management may be asking you, is the system working, and how well is it working? So the ability to be able to pull up a computer screen, log into an interface, and be able to quickly assess the status of your system is obviously one of those things that are incredibly powerful. And so with the Opticom Connected Vehicle Platform, we do have management software available. Looking specifically on the management side, the ability to verify that your vehicles are effectively communicating. Perhaps you want to change your vehicle settings. Maybe your early-late thresholds have changed. You'd like to adjust that. The ability to do all of that remotely. If you need to upgrade your vehicle system software for some reason, maybe there's a newer release that you want to push out to your vehicles. Or as you think about your GTFS schedule data, if you make quarterly updates to your schedules, you need to get those pushed out. There's an easy mechanism now for you to do that from the comfort of your office. And then along with the management side, with the connected vehicle platform, you also get access to a lot of very rich data and analytics that you can then use to analyze the performance of your system and then optimize it based on those learnings. So the ability to look at the performance of your vehicles and your routes over time to see what potential factors could be contributing to your slowdowns or your lower on-time performance. Evaluating the TSP usage along a route to see maybe a vehicle isn't getting TSP and it should be, so maybe you need to make some adjustments to your system either at the intersection or the vehicle. And then lastly, assess things like travel time throughout a trip or your dwell time across stops, giving you more insight to determine what next steps you need to take to optimize your routes and ultimately optimize your overall transit operations. Okay, so that's an overview of the system. I know we went through a lot over the course of the last 30 minutes. I do want to leave you with one final piece, and that's some things to consider on the deployment side as you think about rolling out new technology. So some things to think about are really not just for today and your needs today, but they're also what are your needs in the future. So as you think about any technology, not just TSP or Opticom or GTT technology, but any technology, the questions you need to assess are really what onboard vehicle systems do you have in place today or do you plan to purchase? Look at the intersection side. What controllers do you have? What are your signals or roadway lanes? How are those set up? Are you positioned to do things like queue jumps, or is that something you would like to do in the future? You need to look at the control center or the back office. What ATMS system do you have today? How is your relationship with your IT administrators? Do you have access to be able to integrate through the back office to get communication between the vehicle and the intersection? And lastly, what communication networks are you putting in place, albeit radio, cellular, Wi-Fi, fiber? We've designed this platform to be flexible, to work in any of those environments, but the questions that we would need to ask or we would need answers to before we deploy technology. And I encourage you all to think about these things as you look at any technology, or what systems are in place today so that folks like GTT or others can effectively propose the right solution for you. All right, so to recap, I want to leave you with 3 key things. The first is TSP gives buses the green light to move quicker, cut fuel costs, and reduce emissions. The second, GTT offers a variety of solutions to meet your short and long-term technology goals. And lastly, Opticom CVP is GTT's latest platform, keeping buses on schedule today and providing a platform to build on for the future. All right, so that's all I had today. Thank you all for your time. We're happy to answer any questions after this webinar, but I think we can take a couple minutes here as we close out the webinar to answer a couple questions that we have teed up here. So, Andrea, do you want to walk through those?
Yeah, there were a couple of questions that came in throughout the session that I think would be best here. I know we're running over, so I'm going to try to make these quick. Firstly, how do you connect with the CAT AVL?
Yeah, Craig, I think you touched on this a little bit earlier, but do you want to talk more specifically on the details of the technology that can be used to do that?
You betcha. Very quickly, 2 methodologies, and the most common one is through the J1708 industry standard connection. It's like a Molex plug, and you connect devices together via the J1708. It's Again, it's an industry standard, and many are doing it that way. The other is through a discrete output, where basically power is applied to a specific wire in the installation, and when the CAT AVL, in either case, when the CAT AVL system determines the bus is behind by whatever default you set, say 2 minutes, it basically sends a signal to us either via discrete or J1708 to turn us on or off.
Perfect. Yeah, and I'd also like to add in just Ethernet connectivity. That's becoming one of the standard communication protocols for technology, or I should say communication mechanisms for technology. And so obviously Ethernet could be leveraged as well.
Great. Also here, this came up a couple of times, but is TSP automatically enabled, or does the driver actually have to do something, hit a button or flip a switch?
Craig, do you want to take that one as well?
In the olden days, it used to be flip a switch. I have a local customer here that installed one 20-plus years ago where it's driver actuated, but right now, with union rules, et cetera, the way they are, it's automatic. Again, I mentioned earlier, let the computers do the talking, so it's seamless and automatic. Again, whether it's our ASM software running on the connected vehicle platform or out of your existing CAT AVL. If the bus is behind schedule, the computers do the work to the intersection equipment from the bus to extend that green for the TSP call or truncate the red. So it's seamless, automatic.
Great. So basically, no, they don't have to touch anything. It's all done behind the scenes.
To answer your question, right. No, they don't have to touch anything.
Great. And then one more here. What equipment goes in the bus to make it a smart bus with TSP?
Yeah, Andrea, I can take that one. So the first point I'd make, I guess, is that smart is really relative. So to the customer that Craig just alluded to 20-plus years ago, it probably wouldn't take a lot by way of technology to make that bus smart. It has some technology, but obviously it's pretty dated. But as you think about the realm of TSP, I think the first step in making a bus smart in that regard is getting the core TSP function, and that can be either through a connected vehicle platform or our traditional Opticom GPS system. And then you can take that a step further to make it even smarter by integrating it with an existing AVL or purchasing something like the Opticom connected vehicle platform computer and the ASM application. And then obviously You can take it even further than that to integrate things like passenger counters or more deeply integrate with AVLs. So it really comes down to the integration effort and really at this point what you want to do as a customer and what your needs are as a city.
Excellent. Thank you, Chad. I think that is going to round it out for today, but it was great that so many people could participate in this presentation, and you've asked some really great questions. For those we couldn't get to, we will address your questions individually. But I also wanted to mention that we have recorded today's presentation, so that will be available on our website in the next day or so. And I also want to thank Craig, Paul, and Chad as well on giving this great presentation, and thank you all for attending and your presence and time.
All right.
Thank you.
Thank you.
Have a great day.